The next portion of this video series will discuss solids, liquids, and gases, the phases of matter. So, this is something that's familiar to you all, but we have phases of matter. Now, we need to break that phrase down, because what is matter? Anybody know? Matter is anything that has mass and volume. Now, volume, another way you could say it is takes up space. Okay? So anything that has mass and takes up space. Now, you have mass and you take up space, which means you matter. Y'all know I love my corny chemistry jokes. So phases just refer to the different ways that matter can be found. It can be found, number 1, as a solid, number 2, as a liquid, and number 3, as a gas. There are actually 5 states of matter, but for the purposes of this course, we're only going to discuss 3. The 4th one you might be familiar with as plasma, and the 5th one is actually still very recent and you might not have heard about it. You can research it on your own time. But what we want to talk about is the way they change from each different phase. Now we know if we are looking at water, for example, H2O, okay? H2O stays the same no matter what phase it's in. Its chemical composition does not change. This is just a physical change. As a solid, H2O is found as ice. As a liquid, it's water. And as a gas, it's vapor. Now, we know that when ice melts to become a liquid, we add heat. Okay? We add heat. So I'm going to put a little positive sign there. And I'm going to write to the side, positive means add heat. Now, if I add heat into my ice, that means heat is going into it, which would make it, our vocabulary word, endothermic. When liquid, water, becomes ice, it's freezing. And when you're freezing, you're not putting heat into it. You are taking heat out of the liquid in order for it to become a solid. So I'm going to put a little negative sign here. And we're going to say that negative means to remove heat. And if you're removing heat, that means heat is exiting your system, which, you guessed it, makes it exothermic. So we're just going to make sure we all know our definition of endo and exothermic processes. So then we have the question, okay? When liquid becomes a gas, that's vaporization. Now, you know that liquid doesn't just turn into a gas. You put the water on the stove, you turn on the heat, and heat goes into it, which means it's going to be endothermic. And the reverse, condensation, when the water vapor in the air is cooling down, you might have seen condensation on the outside of your glass at a restaurant when you have a really cold glass. That is exothermic. The heat is leaving the water vapor, okay, so that it becomes a liquid. Now, if you've ever seen dry ice, you've seen an example of sublimation. Sublimation and deposition are the ones that are a little less familiar to us. Sublimation is when we go from a solid to a gas, and that will also be endothermic. We add heat there. Okay. But deposition, when we go from a gas to a solid, is going to be exothermic. You have to take away heat. The heat has to exit the system. So please make sure that you are reviewing, that you know what each of these phase changes mean and the definition of exo and endothermic. When we're talking about the phases of matter, we also need to talk about the kinetic molecular theory. Now, the kinetic molecular theory describes the way atoms move in a phase. Okay, so what this means is when I'm a solid, like in this picture, my atoms have a very little space between them and they're staying still. There's a very uniform structure. When I'm a liquid, I don't really have much of a structure. The atoms are kind of moving a little bit. As a gas, they move around a lot. And as plasma, you're actually charged, but we don't talk about plasma much. But the main thing is the kinetic molecular theory. If you break this down, the word kinetic, you've heard that word when you talked about kinetic energy, the energy of movement. And molecular is just referring to molecules, the way molecules and atoms move in a phase. And it's different for each of the three phases that we look at. So we want to kind of break this down into a graph so that it's easy. We know that our three phases that we're talking about are solids, liquids, and gases. Now, with our solids, liquids, and gases, we need to think about what the shape and volume are. Solids have a definite shape and volume. This means that when an ice cube is an ice cube, it has a particular shape, generally in the shape of a cube, and its volume does not sporadically change. And the movement of the atoms, they vibrate in place. They vibrate in place. Kind of like how in the classroom you sit in your desk and you might be moving your hand, you might be tapping your foot, but your position stays the same. You're not moving all around the room. Okay? A liquid, however, is a little bit different. A liquid has definite volume, but no definite shape. And this means that a volume takes the shape of whatever container it is in. You know that if you pour water in a water bottle, it's the shape of the water bottle. You pour it in a bucket, it's now the shape of the bucket. It takes the shape of its container. Now, the movement is they vibrate around moving points. Now, my example for this, how to explain vibrating around moving points. We were all in elementary school at one time. And in elementary school, when you're going to the bathroom or you're going to the cafeteria or to recess, your teacher has you line up in a line. And you know that you are in a single file line and you are marching with the rest of your class, and there is one person in front of you and one person behind you. And when you're moving in this way, you're moving, right? Your position is moving. You're traveling down the hallway. But your position in line does not change. The person in front of you and the person behind you is staying the same. It's the same way for water molecules. When you're pouring them into a water bottle, the water molecules are going to keep their same neighbors. They're just going to travel together. So it's like keeping your same neighbor when you're moving down the hall. Now, gases are going to be a little different. Gases have no definite shape or volume. Now, I know that you have smelled somebody before you've seen them, right? If somebody puts on way too much cologne in the back of the classroom, it does not take long for someone in the front of the classroom to be able to smell it. And that's because gases expand and fill up the area around them. They have no definite volume, and they don't have a definite shape. We know that balloons can be formed into all different types of shape. And so their movement is they are moving quickly all over. Okay? They are not just vibrating, they are moving quickly. So if we want to refer to which ones have the highest amount of energy, okay, gases have high energy, which I'm just going to abbreviate as an E, and solids have the lowest energy, okay? Which makes sense. If you think about solid as atoms as toddlers, we know that when toddlers have a lot of sugar, they act like a gas. They're moving quickly all over the place. But when we take energy away from the toddlers, right, they've burned out all their energy, they're just kind of vibrating in place. They're sleeping, and they might, roll over, but they are staying still. They have low energy. They can't move. And so that's all what the kinetic molecular theory is trying to discuss there.